The broadcast is now starting. All attendees are in listen-only mode.
Wonderful. Thank you, Adele. So I've just gone full screen mode, so I can't see the GoToWebinar thing asking questions, but I'm sure you'll prompt me if there are any. Hi, everyone. Thank you for spending some of your time with me this afternoon. My name is Jim Webber, and I'm the Chief Scientist on the Neo4j database, and I'm here to talk you through graph databases, Neo4j, and give you a little bit of a hands-on demo of how graph technology and graph databases work. And firstly, just want to say thank you to the eSynergy team for lining this up today and connecting us, as it were. And I hope we'll have a fruitful hour or so together, and you'll be raring to give Neo4j a blast by the time we get to the end of it. So, what are we going to look through today? We're going to take the narrative arc's going to be, we're going to look where we are today in terms of data. I think it's a really interesting time in the evolution of data technology. We've been at the we've seen relational technology establish itself as the dominant paradigm in data, but we've also seen very recently the NoSQL databases come to prominence, and I think we're at an interesting point in the evolution of data technology. I think that will be helpful for informing our choices of data products going forward. I then want to introduce to you Neo4j, and I want to talk about the labeled property graph model, which is the data model that Neo4j uses. And we'll talk through how to model in a graph database. It's quite different modeling in a graph database compared to some of the relational modeling that we may have been used to. And we'll talk about whiteboard friendliness and some other useful concepts. So hopefully you'll get a taste for how you would actually go about building a graph data model and using it in a real app. Towards the end of the session, I'll actually crack open Neo4j, and I'll show you how we can build some very straightforward recommendation algorithms in a few lines of code and a few minutes, just to show you how powerful the graph data model is and how effective it is in terms of being able to rapidly build out some very effective algorithms for real-world use. And I'm happy to take questions at any point through the presentation. Just pop them into the GoToWebinar window, and I'll scrape them and answer them. Or indeed, if you have any questions after the presentation, super happy for you to reach out to me via email, via Twitter, or whatever it happens to be. So, where are we today? We are here. And don't worry for those of you who fleetingly thought, oh my God, that's my screen that he's sharing. We all have lived with relational schemas like this, and they are incredibly complicated. And kudos to us as an industry for being able to work with these kind of schemas. And for those of you guys who are DB specialists, some of the things you can do with relational database and SQL simply amazes me, and I take my hat off to you. This kind of complexity, I'm afraid, nowadays defeats me. But sometimes you feel like this. You feel that you've done the 7 deep, inner, outer, upside down, reverse, left, right, join through all these tables just to flip this one bit from true to false. And so sometimes the modeling metaphor, the table metaphor, and joins just gets in the way. There is some accidental complexity in there which gets in the way of expressing your clear modeling intent. Things like having to express as a user, having to build join tables and so on, rather than the database being able to understand how to connect data adds to that complexity. And then of course there's the additional complexity that once you've built a beautiful normalized model in your relational database, that someone who really knows how Oracle works has to come along and denormalize it for you, which creates an enormous semantic gap between your domain and the data structure as it's ultimately persisted on disk. And that is troubling, to say the least. So along comes the NoSQL stores, and the NoSQL stores promise a different value compared to the relational databases. They're not about building models and querying the models. They're about storing simple data and computing answers. So it's no longer a model-centric query mechanism. It's a kind of raw material data and then compute model. And there are 4 categories in NoSQL, three of which are very similar actually. So we have the key value stores as represented by databases like Era, Spike, and React. And these things have their heritage in Amazon's Dynamo, which was a shopping cart database. And the data model is pretty easy. It's a big hash map, so you can store and retrieve values by key. And these things have reasonably good operational semantics. React, for example, is well reputed to be very dependable operationally, but they have, and that's a plus side of their data model. It's very simple to operationally scale it and make it resilient. The downside is their data model doesn't particularly give you any insight. So it's very straightforward to store a user session by key, but it's very difficult to then splice and dice it in some other way, like what users are buying which products at which times of day and that kind of thing. Something that we would perhaps be able to expect to learn from a relational database very easily. We then have the column stores as exemplified by Apache Cassandra and HBase and so on. And these guys are a bit more interesting compared to the pure key value stores insofar as the columns, the data model is a nested hash map of hash maps. And within this nested hash map of hash maps, sometimes the keys line up, which gives you a kind of natural index through the data. So it gives you a bit more insight into the data. But still, these guys retain excellent characteristics in terms of operational resilience and scale, which makes them a reasonable choice for many disconnected data applications. If you want to collect votes from Britain's Got Talent, Cassandra is the way that is done, and for good reason too, because it's operationally able to deal with the kind of bursty load that such applications deliver. We then finally have ultimately have the document databases as exemplified by MongoDB and things like Couchbase. And these guys, I think, are probably the most familiar to us as developers because the metaphor of document databases is a filing cabinet. So we can store a document and retrieve a document, and we can index through these documents as well. So we don't simply have to store and retrieve by key. And I think that familiarity, that familiar idiom, is one of the reasons why, for example, MongoDB is so popular. Because if I want to just drop a user document into a database from a web application, I can do so very easily. I don't have to do any relational modeling or any of that kind of clever and sometimes painful stuff to get going. But there's a thing about these databases, the key values, the column stores, and the document stores, and it's identified by Martin Fowler and Pramod Sadlage in their book NoSQL Distilled. And what Fowler and Sadlage identify is that these two kinds of databases are aggregate stores. That is, you store some atomic, indivisible value and you retrieve by it. And where you're storing and retrieving symmetrically, these things work pretty well. So if I store a customer, retrieve a customer, works fine. Store a product, retrieve a product, works fine. But if you then want to slice and dice your data, if you want to know about trends, if you want to know what kind of customers buy what kind of products, what products are more popular in different geographic regions at different times of day and different weather and so on, then you really can't do that. There's no notion of a queryable model in these databases past symmetric store and retrieve. So these databases tend to talk much more about computing an answer. They tend to want you to take records out of the database, put them through some compute infrastructure, typically something like Apache Hadoop, and compute your way to an answer. And that's a fine thing to do. The Apache Hadoop can compute answers in parallel at reasonable throughput, but it typically is also at a cost of high latency. Even so-called real-time Hadoop is substantially more latent than we'd expect a typical database query to run. And in fact, I think in a way this is imprisoning our data. So the new NoSQL databases have kind of taken our queryable model and locked it away. And the only way that we can do sophisticated queries with it is by jailbreaking that data and running it through our compute infrastructure. So dragging those records out of the database, running them through our Hadoop infrastructure, and then hopefully using the output of that Hadoop infrastructure to answer a question and maybe drop some more records back in the database. This is pretty unlike what we're used to. And I don't necessarily think it's suited for general purpose query. I'm happy for this to be done perhaps for large latent analytic jobs, but I don't think I'm very happy to put this in between a web request and a web response. which really means we're at a bit of a crossroads in data. And certainly these are interesting times for us. On the one hand, we can denormalize data, create aggregates, create keys and values, create columns, create documents. And that's nice in a way because the data model is simple. I think we can all readily understand it. But we're then forced into a model of query which is much more compute-centric than query-centric. We're going to map-reduce our answers rather than querying for our answers. The other fork in the road is where we maintain a queryable model, but not the relational model, which is not terribly expressive. It's somewhat cumbersome. A richer model of a connected data structure which has extraordinary expressive power, where we can build high-fidelity models and then ask questions of those models via fast graph traversals in order to get our answer. And it's this right-hand fork in the road that we're going to explore this afternoon. So the first thing you'll notice about graphs is they are new. Certainly they're still new to a lot of folks. And my colleague Mark Needham drew this little chart here. And it's the timeline of learning graphs. And some of us may well be down the left-hand side of this chart right now, where we're looking up at this massive learning curve of graphs. And it seems very hard because it seems very different from what we know. And I think a lot of the challenge in that learning curve is not so much learning graphs, which I hope I'll show you this afternoon is very straightforward, but unlearning a lot of the modeling techniques we've used for years and decades in the relational world. But once you've got over that hump in graphs, once you're down on the other side, you'll find that many of the things that were difficult in the relational world are actually very simple in graph world, and you may never want to look back. Now I've just seen my sidebar flip, so let me just double check that. There we go. We have a question. Graph visualization tool question: What customers of Neo4j using? Gotcha. So great question, David. Very quick answer now. There are a plethora of tools out there like Linkurious, like the Keyline software from Cambridge Intelligence, like Gephi, that people are using to do graph viz. And if you hold on for just a moment, a little while longer, I'll do some more visualization stuff as we go through, and I hope to show you that you and others that graph visualization really is a lovely thing. And for the rest of you guys, please do keep questions coming. I'll keep an eye on that sidebar. All right, so to prove this, that graphs are intuitive and expressive and easy, here's the map of many of our lives. Even if you are an out-of-towner, I often throw this graph up on presentations in the United States, for example, and ask some quite sophisticated questions. How would you get from Paddington, which is where the Heathrow Express drops you off, to London Bridge, which is where the Neo4j office is? And it turns out that people can often make a good decision using this graph about how to get across the city, even if they've never been to London before, because graphs are very intuitive. You know that on this graph you're only allowed to visit nodes that are connected. You can't magically teleport from Paddington to London Bridge unless you take a taxi, of course. And so people often say, well, you'll take the green or the yellow line down to Bank, and then you'll change to London Bridge there. And of course, we all giggle because we know the Circle and District lines are awful. And eventually, we worked through, and we were able to find quite the shortest cost path using the Bakerloo and the Jubilee line to get to London Bridge, which empirically I found is the fastest route. But there's something about graphs where you can take a very complex domain, something like a geospatial domain that we have here, present it to people, and they implicitly understand how it works. The mechanics of it are very simple, but you can express solutions to quite difficult problems with them. And all this stems from this chappie Leonhard Euler. So this is a Swiss dude, Swiss mathematician back in the day. And he is working in the city of Königsberg, Kaliningrad nowadays. And he's been set the problem of the 7 bridges of Königsberg. So these 7 bridges cross the river Pregel. And the question posed is it possible to cross each of the 7 bridges without retracing the steps, so crossing each bridge once and only once? And you can imagine generations of empiricists have tried to solve this problem simply by trudging through the town and then being frustrated when they've crossed the same bridge more than once and trying another route and so on. Euler was a bit smarter than that. And in fact, Euler I think of as probably the first the first computer scientist that started to do structured systems analysis and design along the lines of what we do today. So what Euler observed is that actually this real world of the River Prague and Königsberg and so on isn't terribly important to the answer. What he observed, that it's not bridges and land masses and rivers that count, but actually the fact that you have some things connected to some other things. So he was able to take all of that real world noise and from that noise extract the signal, the crux of the problem. And if you think about it, that's very much as we do as software practitioners in our daily lives. We take real-world problems which are hairy and noisy and often ill-specified by some product owner or scrum master or something, and then we have to figure out how to pare away some of that noise and extract the essence of a requirement. And then, as Euler did, we have to figure out how to turn that requirement into an executable specification. Euler took that requirement and he turned it into mathematics, and that mathematics was the graph theory. This is now 277 years old, so this is a mature branch of discrete mathematics, and has formed since then very mature branches of social sciences and network science as well. So this is no flash in the pan. It's 230 odd years older, for example, than Codd's relational model. So from that, the beginnings of around the 7 bridges of Königsberg, we've now, perhaps more so than ever in the last 10 or 15 years, being very impacted by graphs. So we have the interest graph, we have the social graph, we have the telecommunications graph, we have this physics graph that I don't actually know what it means, but it's a graph and it's physicsy, and it shows that graphs aren't just good for explaining who your friends of friends are, or who you might want to go and have a drink with after work, or who you put the next meet that you might want to go to. But you can express fundamental scientific problems also in a graph. This is not a graph. I'm definitely now, having been living in graph world for quite a while, that these are charts. So I will use the word chart for these rather than graph today. So can't I do this in my relational database? What if I have a customer who has many accounts, and I wanted to perhaps get an overall position over those accounts, a common enough problem for retail investors. And in a relational database, we might have a structure like this, where we have a customers table and an accounts table, and we might have this joint table in the middle with some customer accounts. And of course, with our SQL prowess, we could probably figure out how to make that work. But actually, much of this is accidental complexity. The fact that these are tables is not terribly important or enjoyable. In this case, the crux of the matter is that I've got a customer called Alice, and Alice has some accounts that I would like to get an overall position of. This stuff in the middle, this customer accounts table, is some accidental complexity forced upon me by the limitations of the data model I'm using, in this case the relational model. I'd really like, logically, simply to express it like this, that Alice owns so many accounts, those accounts have balances, and I'd be able to sum over those balances. And in fact, in a graph database, this is exactly how we would represent it. The customer Alice would appear as a node. The relationships would appear as relationships. They are directed and they are named. The accounts would appear as nodes in the graph, and we can put properties in them like balance and so on. So this data model is high fidelity. It has low accidental complexity. You have this very small set of modeling components, nodes.
You did it.
To build extremely sophisticated domain models. Let me just check there. Nope, still good. Okay. And this is the essence of Neo4j's property graph model. So we have nodes with labels, and those nodes can contain properties. We have relationships, which are named, directed, and they can contain properties too. Relationships in Neo4j, one of the constraints we import is that relationships can't dangle. They always have a start node and an end node, and they can loop back to the same node if you so choose. So, given those modeling primitives, how might we begin to model a domain? We've seen the very simple domain there where Alice had several accounts, and we would be able to give her an overall position at relatively low cost. Neo4j, for example, would be able to traverse those relationships between Alice and her accounts at the rate of about 1 to 2 million relationships per second, per thread, per core on my fairly reasonable laptop. So this is also quite a performant data model. But if you were faced with the task of modeling a domain from scratch, then actually the best place to start, as always, as with any domain model, is with a whiteboard. Now, this slide deck comes from my friend Chris Leishman, and Chris is one of my colleagues who lives in the US, and he spends a lot of his time with customers, so he makes sure that customers are super happy with Neo4j. However, he absolutely abhors the air traffic system and the airlines in the US because he reckons that they are pretty awful in terms of punctuality and reliability. So he has been trying to figure out by capturing reliability data what the best flights for him to take are. So he lives in San Francisco. Often he'll spend time on the East Coast with finance customers, government customers on that side. And the last thing he wants to do is have be cancelled or stuck on the tarmac or whatever. So how would he go about modelling that? Well, some of the cool concepts, of course, are a flight. And a flight has an origin airport and a destination airport. And this is kind of like the general model. Flights start somewhere, they go somewhere. And in fact, some flights may even have intermediate destinations too. But that's not really the way we model in a graph database when we come to put it in actually in the store. This is more of a kind of abstract schema that we might use just to describe the overall model. Really, in a graph database, we deal with instances of things. So this is a particular flight whose origin is San Francisco and whose destination is JFK. And that flight will have a number, and it will have a scheduled time, and blah, blah, blah. And here we're saying, of course, that San Francisco is in San Francisco and JFK is in DC. This should rankle, right? Because, of course, JFK isn't in DC, but there's something inherent in graphs when you visualize them, to come back to the earlier question, that actually when you're looking at the structure or the content of graph, errors seem to stick out in a way which is far more obvious than when you're confronted with page after page of a table. I think that's a lovely inherent property of graphs. But my friend Chris has been graphing these flights over time, and he's been looking at delays due to weather, diversions caused by weather or other logistics failures, and indeed cancellations and the reasons. And so, for fairness, Chris started to model this in a relational database, so to give you a fair comparison. And the schema he came up with was kind of like this. So you can see all of the detail in there, and even me now as a long since not a relational database person, I can kind of understand that. And then Chris told me that he then wrote this SQL to figure out the crappiest possible flights. This SQL is not easy. And I found out actually that Chris was slightly fibbing to me, and he got one of our young guns who vaguely still remember SQL to write this, because he couldn't deal with all of the inner joins that it took to get this answer. This is a fail, right? This is a page full of SQL. I don't have any confidence that that SQL will perform because of the several layers of joins. I have no idea what intermediate sets will be produced. I have no idea what the latency of that query is. And I also know that query is big enough that I'm positive that there's a bug or two in there. That is a fail. So, back to our graph. This is the kind of graph that we're looking at. Flights have an origin, a destination. They can be cancelled, they can be diverted, they can be delayed. If you plot that out over many flights, you get this kind of graph. So this is an actual graph of flights going around the United States, around LA, Chicago, and Dallas and Atlanta. And Chris has been graphing these and using them to help direct some of his flight choices. So how would I query that in Neo4j? Well, actually, the lovely thing about graphs is that the structure of the graph guides the query. So if I'm looking for reasons why, for example, a particular flight is cancelled or how often it's cancelled, the structure of the graph guides my query. So what I'm going to do here is I'm going to take the structure of this graph and I'm going to turn it from my lovely keynote graphics here, and I'm going to turn it into ASCII art. And what I've got here is a flight, F, which has an outgoing relationship origin to some other node, which I'll label O for origin. That same flight, F, which has an outgoing destination relationship to the destination, which is JFK in this case. And that same flight, F, has an outgoing cancelled by relationship to some reason, which I'll label R. If I then flatten that out, what I actually have here is a legal Neo4j query. In fact, I can simplify it a little by using that flight twice. And what this says is, hey, database, find me patterns where I have some flight F, which has an outgoing origin relationship to some other node O, and it also has an outgoing destination relationship to some node D, and where that F, the flight node, has an outgoing cancel by relationship. So we're looking for cancelled flights. And then we're constraining it, and it's always saying that the origin is SFO and the destination is JFK. And then we're returning the reason's name, and we're returning a count of the reasons, and we're ordering by the count of the reasons in a descending fashion. So we're looking for the most popular excuses for cancellation of flights between between SFO and JFK. That is a very simple query. Most of it came just by swapping out PowerPoint drawn graphics for ASCII art, and this is the heart of Neo4j's Cypher query language. That these match clauses allow you to express patterns in a very idiomatic, graph-centric way. You draw the graph pattern that you're interested in ASCII art, and the rest of it is simply adding constraints. The question like lit. Question on cancelled by relationship. If a flight is cancelled multiple times, that is an awful thing to happen if your flight is cancelled multiple times. But yes, you could happily model that as having multiple cancelled relationships. Or indeed, you might treat each cancellation as a separate event and form a linked list of cancellations. So you have to have a provenance graph of just how messed around your airline, or how much grief your airline has caused you. And do you have multiple relationships? Yes. You can have as many relationships as you like between nodes. You can have duplicates if you want to, if they're meaningful in your domain. You can relate any node to any other node in any direction with any name as many times as you like. So it kind of, as an aside, this is one of the reasons I'm desperately unhappy that the relational databases are called relational databases, because graph databases clearly are far superior for relationships. Fine. And if you run that query in Neo4j, and using Chris's data set, you'll find that you'll get this kind of answer, where often it's the weather that causes problems. So there have been 4 cancellations due to weather at the last point where Chris updated this, 2 because the carrier couldn't hold up their end of the bargain. Basically, the airlines are being terrible, and 1 because the National Air Traffic Service decided that route couldn't run. So Chris could now perhaps pick a different flight, perhaps go via intermediary, see if going via Chicago is any better, and so on, in order to optimize his route. And that's a very practical and personal application of graph technology, but equally it's actually very accessible. This very useful algorithm is expressed in 4 lines of Cypher query language. And I think even if you haven't seen Cypher before, there's enough affordances from SQL that you kind of get where it's going. And I think the ASCII art style query is very accessible to even those of us that haven't seen it before. So my graph is a bit different. So Chris's graph was all about efficient flying around the United States. The second thing I ever did in Neo4j, and this was back in 2008, 2009 maybe, 2008, was a proof of concept for one of the large retailers around recommendations. And we all know back in the day what used to happen was you'd swipe your loyalty card at the checkout, and then something was happening in the back office, and a couple of weeks later you might get some vouchers through your door, and at which point you pick up the envelope and say, oh, that's spam from the supermarket, and you'd immediately drop it in the recycling, because who wants spam from the supermarket? Things are better today. We've now shown that you can do these things in a performant enough manner that you can do it inside the point-of-sale terminal. But back when we did this proof of concept, that wasn't necessarily a well-known outcome. So here's a graph of people who buy stuff. And this is a graph that's very dear to my heart because Mike could well be me. So you can see that Mike here has bought some products. He's bought some specific products. He's bought an Xbox. He's bought some Stella. And he's bought some dry nights. And it's not diapers, of course. In this country, it's nappies. So this guy has bought some booze, he's bought some nappies, and he's bought some consumer electronics. I think this is a pattern for young fathers. So the idea here is that you buy some nappies for the nipper, and then you buy some Stella because parenthood drives you to drink, and then you buy an Xbox because when you finally got the little blighter to bed and he's gone to sleep, all you want to do is flop on the settee, crack open the beer, and play a bit of Xbox for 20 minutes before you hit the sack yourself. So I'm in the middle of this myself, and so I can attest that this graph is a high-fidelity representation of my life. So the pattern we were looking for was young fathers. This was for the proof of concept. And what the psychologists at the supermarket are telling us is, if you can observe this pattern in real time and print a voucher and put it in the person's hand, it's far more likely to change their buying behavior than if you post a voucher to them. Because it turns out that as humans, we're not psychopaths by and large, and if someone hands something to you, you will pick it up and you will look at it and you will read it. I found this out at first hand when I worked in China. I can't read Chinese, but China has a very business card-centric culture. And when I'd be introduced to people, we'd swap business cards, and I would look at the business card I'd been handed and think, well, those are very pretty pictures that I can't read. But you look, and that looking has an effect. And the psychologists at the supermarket know that very well. They also pointed out that although we thought this pattern represented young fathers, one particularly sharp person pointed out that this pattern of buying beer, buying nappies, and buying Xbox could also be a pattern for very hardcore gamers. Yuck. Anyway, so that's one pattern. Another pattern that's interesting is this pattern. This is Joe, where Joe has bought nappies and beer. So we think clearly he's got a young child maybe that he's looking after, and he needs the nappies to keep the kid dry, and he needs the beer to keep sane. But we noticed that Joe hasn't bought an Xbox or a PlayStation or whatever it is. So what we'd really like to do here is make Joe buy an Xbox. We'd like to persuade him to buy an Xbox. And one of the ways we can do that is by observing that Joe hasn't bought an Xbox, but otherwise he is a prime candidate for a young father, and young fathers should have an Xbox. Can we print out, as he goes through the checkout, a voucher for him that would give him some promotional discount on an Xbox for the next 48 hours? And that was our target. Of course, some of the guys said, well, of course, we can simply pre-compute this. We can do a big batch job, and we can pre-compute this and deliver recommendations seemingly in real time, but really have them batched overnight. And the psychologists were not terribly keen on this, because they told us that if there's one thing better than having worse than having a mediocre recommendation, that is being recommended a product for which you don't really care. It's being recommended or being given money off something that you've already bought. So, for example, you kind of, right now I'm buying some booze, I'm buying some frozen peas, some pasta, I bought an Xbox, I bought some cheese, blah, blah, blah. And then last night you pre-computed that I should have a voucher for a PlayStation. Well, when you hand that to me and I look, and in my arms I now see an Xbox, it feels that actually you're just trying to humiliate me. I've just bought an Xbox at full price, but you pre-computed yesterday I should have money off a PlayStation. And so actually the psychologist told us that was an extremely poor indicator for success. So we couldn't rely on pre-computing these things. We had to be able to take the customer's buying history right up to the latest purchase into account when we're going to make a recommendation. And that, of course, for many of us is not constrained by a point-of-sale terminal, but it means that we can do this in between a web request and a web response. The database has to be fast enough that you can fit it into the kind of millisecond scale that HTTP web request, web responses expect. So let's go to the question. How can I model the following? There is no following on that question, I'm afraid. Marvin, I'm going to take the best practice question at the end, if you don't mind, because that's rather more lengthy, and I don't think that good quoting on standard RDBMS. I'll cover that one off at the end if you don't mind. So this is how a recommendation would look in Neo4j Cypher. In fact, oops. All we're saying here is match some customer that bought something that happens to be in the baby category. And this in star means that's any depth, so anything that's connected to baby. Match where that same customer bought something that is in beer at any depth, so in alcohol, or indeed probably in alcohol at any depth, and match where that same customer has not got a relationship marked bought between the customer and something in the category of console, and then return the customer. So what you're doing is you're matching to that pattern, has bought beer, has bought baby stuff, and then you're looking for the sales opportunity, which is, hey, this customer has not bought anything in the console category. Let's print out the voucher for them and try and influence their behavior. And that can be done in real time. This query will run in milliseconds on Neo4j, even on very large hardware, because in a graph query, the latency of your query is proportional to how much of the graph you choose to explore. It's not proportional to how much data is in the database. There is no intermediate set or join problem in a graph database. So let's dig deeper in that. So what you've seen so far has been PowerPoint or Keynote driven. I'd like to show you how Neo4j works for real. So I'm going to pop out of Keynote and I'm going to pop into Neo4j. So hopefully on the screen you can see the Neo4j workbench. This is the Neo4j 2.0 workbench. It's a REPL. So up here is where we start typing query, and then here in the main area is where we will get results back, and they're going to be visualized for us. So in fact, the easiest query I can type is match everything in the database and give it to me back. And because this is an empty database, it says there's nothing to be seen. No nodes, no relationships, just as we'd expect. That's fine. So what do I want to do? I want to insert some data into the database, and I'm going to insert a simple retail data set. So the retail data set is pretty straightforward. I'm using this term here, create, and I'm trying to create nodes with some values in them. So here I'm saying I'd like to create a product, something labeled product, and I'd like it to contain this data. That is to say, I'd like it to contain a description, sliced bread, and I'd like it to have this stock keeping number. And because I'm going to refer to this node that I'm creating later on in the script, I'm going to give it the name bread. So this is the variable name. And I'm going to do that for butter and toothpaste and cereals and pasta and milk and so on. I've then got some kind of domain-specific stuff going on here. So this is something that a domain specialist would know. So I'm adding some relationships between those products. I'm saying that bread is complementary to butter, and that milk is complementary to tea, and so on. So there's some domain expertise here, some ontological expertise that's gone into this data set that starts to say how things are related. Obviously, toothpaste does not go well with tea, so there is no complementary to link. I'm not even sure that's spelled properly. Apologies for that. Then I've got the transactional data. So I've got a bunch of baskets that a particular customer will have bought. So here I can see I've created a basket B1 on a particular date, basket B2, and there's a linked list of baskets. So B1 precedes B2, and I can see that this particular customer, Alice, has saved B1, so it's some basket she's saved, maybe she'll retrieve it later. She's bought basket B2, and she's currently working on basket B3. So that's my transactional data model. And if we go a bit further down, we can see the contents of these baskets. So basket B1 has some toothpaste, basket B2 has some toothpaste and some bread and some butter, basket B3 has bread and butter and so on. And I've done that for several customers, for Bob, for Alice, for all the things, for all of their purchase history. Of course, in a production system, these would be gathered in line. And then finally, at the bottom here, there is some social data, there's some friend data. So this is the kind of thing where, right now this is kind of social selling, saying Alice is Bob's friend, Alice is Dora's friend. In the actual retail example, friend data really isn't available, but demographic data is. So they know where you live, they know what kind of area you live in, they know whether you drive a Prius or a BMW, they know whether you read the Daily Mail or the Guardian, and they can lump you into certain demographics to kind of help with the social selling aspect here. For this example, I've just used friend because it's a bit easier to understand. So Alice has a bunch of friends, Bob has a bunch of friends, Charlie and Dora have a bunch of friends. So I'm going to go ahead and run that, and it's completed, it's loaded a bunch of data into the database. So now if I say give me everything back from the database, match subnode, return any matching nodes, I will get back this kind of thing. So this is a a graph of of the data we just poured in. So this is fine, and you can imagine that for a real data set, this would be far, far bigger than what I have here. Let's just check on this. Jim travels from A to B, Tom travels from D to B, C. Yes, so in this particular case, I'm just answering the question about traveling. I think I would pull out the notion of a journey as a node and say that Jim participated in a journey. The journey was from A, it was to B, it was on a particular date, it was with a particular airline, and so on and so on. So in the book graph databases, we actually call out that issue about accidentally hiding entities inside relationships. And I think a journey will be a first-class entity for any realistic travel recommendation system. Sorry, to return to the graph. So now we've got our data set, small as it is, but representative. What are we going to do then? Well, one of the things we might do is say, well, okay, what are the top 5 products? This helps the supermarket a little because it knows the popular products. Maybe they can realign their supply chain because of it. The query is very simple. It says, find me a pattern where I have some customer which bought something that was in some product category. And I'd like to return that product. I'd like to return the count of the product ordered by the product count in descending fashion. And I'll limit it to the top 5. In fact, I might limit it to the top 3. And I'll run that. Off we go. And we get 3 products back. We can also view this in a columnar form. And you can see that the top selling products in this supermarket are milk, bread and pasta, 5, 4 and 3 sales respectively. It's obviously a very small supermarket. So that's all well and good. It means a supermarket can look for its best sellers and run promotions on them and make sure that they're always in stock and so on. But it doesn't really help the individual shopper. So the individual shopper really wants better recommendations than just, hey, here are the top sellers. That's the supermarket side of things. What about Alice's top 5 products? So we can take the top 5 idea and start to personalize it. So this is actually very similar to the top 5 products or top K products that we just saw, insofar as the pattern we're trying to match is where a customer bought something, and that product bought something in a basket, and that product was in a basket. But here we're constraining it such that the customer has to have a name property, and the value of that property has to be Alice. So we're saying, what are Alice's top 5 products? And if we run that, we get something quite different. We get that Alice buys a lot of toothpaste, she buys butter, and she buys bread. Because she's only bought 3 items, we see that those are her top 5. And you can see then that in a kind of supermarket or a retail environment, someone's about to check out, click the checkout button on their web property. Immediately you do that query. It comes back in a few milliseconds. And you say, hey, Alice, you normally buy toothpaste. You haven't bought toothpaste in this basket. You should add toothpaste to your basket. So you can start to add value and start to change the customer's buying behaviors there. So that's good. Alice's top 5 products. But what the holy grail of retailing is at the moment is social selling. So using your peer group to influence you to buy things. And we've all seen this, I think, particularly in IT. Nobody needed an iPhone 5. Your iPhone 4S was fine until that guy came into the office that day, and out comes the iPhone 5, and suddenly you're like, oh. And then mysteriously a lot of iPhone 4Ss got cracked cases and had to be replaced. So this kind of peer pressure idea. And so what we might do here is use knowledge of what Alice's friends and friends of friends have bought to put pressure on her to buy things. Because, of course, you don't want to be the one weirdo who doesn't have tagliatelle in their cupboard when all of your friends do. And so this query is a bit more interesting. There's 2 aspects to it. At the bottom here, there is that now familiar looking at top 5 products. But here, at the top of the query, these lines here, lines 2 and 3 and 4, we are looking for a social network. So what this says is, find me some customer which has an outgoing friend relationship, either at depth 1 or depth 2, so that's friend or friend of friend, to another customer which we'll call friend. And then we're going to constrain it. We're going to say that the customer must have a property called name, which has a value Alice. And the customer and the friend can't be the same. So of course Alice could have a friend, Bob, and Bob could be Alice's friend, so you don't want friend of friend to be yourself. And then we're going to pipe the results of that social search, that search through the social graph, using the with clause into the second half of the query, where we say, given the friends that we found in the first bit of the query, find us the products they bought in some baskets, return us those products, the count of the products, order by the count, up to 5, and present in a descending fashion. So if I run that, now I start to get some interesting feedback that Alice's friends buy a lot of whole milk, a lot of unsliced loaves, a lot of pasta, a lot of tea bags, cereals, and so on. So if Alice is missing any of those things in her basket, we can use that social peer pressure to try to finally adjust her buying behavior so that she falls into line with her peers. And again, in a realistic retail scenario, again, this wouldn't be friends, but this would be demographics. So people like you also bought X. The people like you also bought quinoa or some other, esoteric food stuff or whatever it happens to be. And then finally, we can use our internal knowledge of products in order to be able to upsell. In fact, upsell was the first thing I ever did in Neo4j back in the day when it only had a Java API and I was a Neo4j user, not a Neo4j developer. I was using it to upsell people for better phone and internet bundles. And this idea can be generalized, and this is a complementary upsell in retail. And this query says, well, we want to match where some customer is working on a current, has an outgoing current relationship to some basket, and where some product is in that basket, which is complementary to, and I can't spell complementary, I apologize, to some other product. So we're looking for the pattern where there are complementary products in the current basket. And because this is Alice who is logged in, we want to make sure that the customer has a property Alice with a property name with a value Alice, and will return the complementary item. So hopefully if Alice has bought bread, we should recommend butter. When we run that, that's pretty much what we get. Given Alice's current basket, she will be recommended to buy butter, some sliced bread, and unsliced bread. You can see when I wrote the data set, I was really thinking about making toast. So there we go. That's a handful of very simple recommendation queries, going from kind of just simple top K queries all the way through to social selling and using specialist knowledge to influence sales. So let me whip back into Keynote. But Neo4j isn't just good for retail, it's not just good for social, it's actually good as a general purpose database. And we see people using graphs all over the place now in recommendations, in routing and data center management, in time series, in biology, in entitlements in finance, in pricing in finance. We see it in security because graphs are way better than LDAP. We see this in BI, we see this in analytics and so on. And of course, we have things like spatial and product catalog are also very graphy domains. It used to be that people would say, oh, I need social, I'll get Neo4j. But I think graphs now have matured, and we understand that graphs are a general purpose idiom in the same way that for many of the last few decades, we've thought of relational databases as being a general purpose idiom. And graphs simply aren't, Neo4j simply isn't controversial anymore. So this is a somewhat out-of-date list now, but there are a bunch of organizations that have adopted graphs very successfully, adopted Neo4j very successfully, and some of them are organizations that you would definitely think are conservative. However, if the likes of eBay, the likes of HP, if the likes of Cisco and Deutsche Telekom are adopting Neo4j, it really has crossed the chasm now. Neo4j is no longer a curious member of the NoSQL fraternity, but is actually an uncontroversial database to use for solving connected data problems in real time. I would point you guys to some resources. You can download for free a copy of the O'Reilly Graph Databases book. If you go to graphdatabases.com, you can grab the full free ebook that I wrote along with my friends Ian Robinson and Emil FM. Please do go grab yourself one of those. And recently, we at Neo4j published a completely free online training, interactive training. You get to type queries and get visualizations and so on. If you go to neo4j.org/learn/online_course, you can register for that and go through a bunch of very sophisticated Neo4j training at your own pace. That's all I've got to share with you from my side today. Thank you to eSynergy for hosting, and I guess I'll switch over now and we'll take any questions. So if you do have more questions, now's a great time to start typing them. And for some reason, okay, for some reason the questions have disappeared. Questions. There we go. In console, blah, blah, blah. Yeah, so there are two consoles. You're absolutely right. I would the slash browser console is older. It's a version that came shipped with our Neo4j 1.x release. The difference is the new one's better, and I think I would default to that all the time. The old one, it's there because some people liked some of the JMX affordances that it gave, but I think for dealing with Cypher, you really want to be in the new REPL because it's much lovelier. So anything similar to taking stale data? The answer to that is no. Neo4j is an ACID transactional database, which means at write time, everything's consistent in the database. So no, we are not an eventually consistent database. We are an immediately consistent database because we think that a database should look after data, and ACID transactions are one of the best ways, or if not the best way, of ensuring that your data is safe. We also, the database was built in Sweden, and of course, if you think about what else comes out of Sweden, it's Volvos. And a Volvo is basically a set of wheels upon which hundreds of airbags are mounted. And we have the same kind of safety-first attitude in the database. The very worst thing the database can do is lose or corrupt data, and Neo4j does not lose or corrupt data. Another advanced question, if I may. So the question is, for one customer, the baby alcohol Xbox question is straightforward, but if you've got thousands of products, millions of transactions, does a graph database facilitate better, newer algorithms? Or are the algorithms the same one that you use on a relational database? So no, the algorithms are similar, because if you try to do recommendations in a relational database, you're going to end up faking connectivity anyway. So what a graph database allows you to do is bring into play all of those algorithms that you learned and forgot from Algorithms 101. So you can do things like weighted graph walks, you can do sampling of relationships, you can do cosine similarities and all that kind of stuff very, very conveniently in a graph. But because the cost of traversing a relationship in Neo4j is so trivial, it's about 1/2 millionth of a second on my laptop per thread per core, you can choose to go very deep in the graph or very broadly in the graph, and effectively you can choose how much of the graph you want to explore in order to give a better or worse quality recommendation. If you have tens of seconds of opportunity, you could probably explore the whole graph. If you have only, say, 200 milliseconds of opportunity, you might localize that search more and give a slightly worse answer. What's the easiest way to get data into Neo4j from a SQL DB? The absolutely easiest way to do that is to use Neo4j 2.1, which is due out next week. And Neo4j 2.1 has built-in load CSV functionality. So do an export in CSV from your existing database, do an import into Neo4j. The one thing you'll have to remember there is that often the model in your old database and the new database won't be one-for-one compatible. So when you're doing the CSV export, remember that you're going to have to do a little bit of model translation as you're doing it. So if you look at Neo4j 2.1 and you Google for Neo4j load CSV, that will be absolutely the easiest way of doing an ETL job with Neo4j. How mature is the PHP module driver? Very. So the Josh Adele is the main Neo4j PHP guy, and he built that module because he had production Neo4j instances that he wanted to use from PHP. He actively maintains it, and the PHP community around Neo4j is very mature. Josh is also very active in our community, and he's super helpful if you ask him questions about it. How do I compare NeoDB versus an operational store? Sure. So Neo4j is just a database. In the same way that any other reasonable database deals with transactions, Neo4j does transactions. The difference between Neo4j and Oracle, apart from millions of dollars, is that Neo4j simply has a different and I believe better data model. But in terms of its operational characteristics, it's going to be very familiar to you. It's ACID transactional. It runs on the JVM stack, so your ops team already knows how to monitor it, and it has all the kind of monitoring and alerting affordances that you'd expect. It clusters for availability and scale and so on. So I think you'll find that the only exciting part about Neo4j is the data model and the query language, and I hope you'll find that Neo4j operationally is terribly boring, which is a good thing. Does the community version provide HA support? No, it does not. The enterprise version of Neo4j, which is also open source, provides clustering. The community version of Neo4j does not provide clustering. The two editions, Neo4j Community and Neo4j Enterprise, are licensed slightly differently. Neo4j Community is licensed under the GPL license. Neo4j Enterprise is licensed under the AGPL license. But it is only Enterprise that provides continuous availability features. Community does not. Having some experience with CouchDB, is it possible to add file attachments? Because I don't want to store them in S3. Yes, absolutely. Neo4j can store arbitrary JVM data types. So it can store any of the Java data types plus arrays of those data types plus strings. So effectively you could store, if you wanted to store a JPEG, you perhaps create a node which has kind of media type application/JPEG, and then you'd have data, and you'd store the JPEG as a byte array. And if you were being super sensible, you could have many versions of those nodes all connected to a logical node representing the resource, and you'd have perhaps different resolutions of the JPEG, different encodings of the movie or the music or whatever it is. But yes, absolutely. You're welcome, Patrick. How do you scale out a GraphDB to multiple servers? So Neo4j Enterprise enables you to scale to create a cluster, and it scales in a very similar way to the way that MySQL scales. So if you're used to that, it's a write master with read slaves kind of idea. Neo4j has its own Paxos implementation that deals with master re-election, but effectively you add more machines and you get more throughput. Is there any plugin to automatically pull social information after the user code? Not that I know of. However, several organizations do that with Neo4j. Effectively, they have harvested social data from Twitter, from Facebook, until Facebook recently changed their terms and conditions. So people like Glassdoor, people like Snap and Tinder and so on, they're all big Neo4j users, and they have done work to harvest, with permission, data from Facebook, but I do not think that they have packaged it into any useful plugin. That'd be quite cute though if you do that. That'd be interesting to open source. I think people would love to be able to pull their network from Facebook and analyze it in Neo4j. Sharding is to be handled from the application side. At the moment, if you want to shard, yes, you do it in the application. However, given that we have people running with bigger graphs than Facebook, so for example, Snap runs with somewhere of the order of 130%, a graph that is 130% the size of Facebook. If you're anywhere between 0 and a bit bigger than Facebook, you don't need to shard. Graph sharding is a tough issue. When you shard a graph, you're making a trade-off, because some of the relationships you're going to traverse, which used to be traversed cheaply, 1/2 millionth of a second locally, now cost you an Ethernet scale traversal. So you'll go from nanos, potentially up to millis. And so sharding is not to be taken lightly. We do have some R&D work going on in Neo4j to address graph auto sharding, and that will come to market, I think, in the next year and a half or so. But it will be when we're confident that we can match the performance for the most, for the like 99.9% percentile or 95th percentile or whatever it happens to be of the purely local Neo4j. So if you are interested in graph databases that shard, be aware that they will be slow. And if you're interested in graph databases that use eventual consistency, be aware that they will eventually corrupt your data. Does Neo4j provide access rights to the data? Okay. No, at the moment, Neo4j provides an interface into which you can inject your own rules about access to the data, but it does not come out of the box with any access control. I mean all on the same node, I mean all on the same machine, or all in the same, with a replication, with a full replica of that machine, of that data on every machine in the cluster. Node, of course, in Neo4j has a very different meaning, so I assume you meant machine there. Someone in Neo4j said partitioning of nodes is challenging due to tight coupling between the nodes and relationships. That partitioning is still possible. However, algorithmically, partitioning a graph is NP hard. So if you just want to partition a graph and try and get an optimal partitioning, that's something that you can't do for any meaningfully sized graph. We have some ideas in Neo4j how we might avoid some of that NP hard partitioning by giving hints based on the domain. But as I said, avoid sharding for now, because unless you are bigger than Facebook, you don't need to shard on Neo4j yet, because the vertical scalability of graphs is absolutely astounding. You'll find that what used to take several writes in your relational database will take one small write in your graph database. You'll find something that used to take, used to chew up your CPU and your memory with like massive internal, internal sets being generated in your relational database is a simple pointer chase in Neo4j. So you're going to get a lot of work with the same kit in Neo4j long before you start thinking about sharding. And by the way, sharding is a horrible thing, truth be known. Some people get excited about it, but I do find it disappointing that some databases force you to think about sharding. I'm much more enamored with the databases where you just add more hardware, get more throughput, and you don't need to think too much about it. Yes, thanks. You're welcome. What's the best practice for coexisting? Thank you for bringing that up again. So Neo4j is operationally boring, as I mentioned earlier, and Neo4j 2 actually, it has a transaction manager, it's JTA compliant, so you can actually run Neo4j in the same transaction manager as your Oracle database. So you could keep your Neo4j database and your Oracle database synchronized transactionally, so they will be consistent when a query finishes. I think that if you are from that kind of mindset, if you're on a kind of enterprise background and you're comfortable with using enlisting Neo4j inside Oracle's transaction manager, or using Neo4j's transaction manager to run another database, that's a really strongly consistent way of doing it. Otherwise, people have taken various different approaches. People have used queues, people have used feeds. Some folks, some early adopters of Neo4j actually used a queue which would only be updated every 4 hours, which was weird. When we asked them why, because they could have done this in milliseconds, they said, oh, because our Oracle system expects a feed only every 4 hours. So if you don't want to go down this kind of JTA route, then there are several other kind of enterprise integration routes you can go. MuleSoft, for example, has Neo4j connectivity, and that will help there. If I want to build a solution to Neo4j, who can I talk to with help for development? Well, Stuart, you can either talk to us guys here at Neo4j itself, or there's a brilliant community around Neo4j online. There's a great Google group. Stack Overflow community for Neo4j is enormous. If you happen to be in any of the major cities, including London, then there's a great Neo4j meetup scene. If you can get to London, then Neo4j runs a meetup every month on the last Wednesday of every month. You may have missed yesterday's, which we hosted in a pub, and so I'm glad this talk was in the afternoon, because I wasn't too brilliant this morning. But yeah, there's plenty of people you can talk to, and there are also a bunch of consultancies who can help you build software. If you want to be hooked up, connected to any of those, please reach out to me. I'll give you my details at the end of the questions. Any name suggestion for a graph database viewer UI tool? Yes. Firstly, start with the Neo4j browser. You will get some good visualizations, just like this kind of thing. Just using the Neo4j browser, you can make this look nice. So you can color it and blah blah blah. You can really start to do some some fun things with the Neo4j browser. When you outgrow the Neo4j browser, then I think that you should start to look at things like if you want to use something cheap, Link Curious is one thing. Gephi is free and open source. However, if you work for an organization that has money to spend, there's a company called Cambridge Intelligence, which has a product called Keylines, and they produce some absolutely astounding visualizations. They have their roots in the intelligence community, and they have some just brilliant visualizations that you can use. Any native plugins? Yes. So Neo4j, as you can imagine with the 4j bit, is a Java-based system. So if you are a Java person, you could actually choose even to go as far as to embed Neo4j inside your application. But there are native Java APIs for Neo4j. You're looking for the core API or the traversal API, and they will give you an idiomatic Java view into the graph. You don't necessarily have to use Cypher. Is it possible for using Neo4j to build analytics? Yes. Yes is the short answer. You can track clicks, and then you can analyze across them. There are people in the Neo4j community, for example, Nigel Small, who are very used to dealing with analytics. I'd suggest that you bring that onto the Neo4j Google group, because there'll be a lot of people who can give you pointers there. Thank you, Marvin, you're welcome. Any Neo4j training in Asia? Infrequently, I'm afraid. So we don't have a footprint in East Asia or Southeast Asia. There is a lively community in India, but it really depends where you are. Asia is a big place. Occasionally we train, we have done trainings in the past in Singapore, we do trainings in India. If there's no one near you, and as I say, Asia is a big place, I would direct you towards the Neo4j online training, which follows a very, very similar syllabus to the staff trainings that we offer. Already emailed me? Yes, you have, Stuart. I saw that just as I was about to join this conference. You're in Singapore. Then you have a reasonable chance of getting some local training. I'd ask that could you perhaps email me offline, and I will hook you up and see if we can get enough takers in Singapore that I can get a free trip to the sunshine. Phil, do I mind quickly typing out the name of the company? Not at all. So the people who, apart from us who do the Neo4j workbench, there are Link Curious, there are there's Cambridge Intelligence, and there is Gephi. And there are probably more that I'm forgetting now that I'm in front of an audience, but those are the three big ones that come to mind that lots of people use. Question organizer, do you want a copy of this webinar? Adele can answer that, but I believe that would be fine. Phil, I think I've got you covered. I've just typed out those names into an answer, so you should have those. And I appear to have reached the end of the question list. Brilliant. So let me flip back here then. So you can get hold of me on Twitter. You can get hold of me via email. And those are my details there. Hopefully you guys can see them on the screen. And since there are no more questions in the chat channel, I guess I say again, thanks guys for spending your afternoon or evening with me. I hope it's been useful for you. I'm really happy if you want to reach out to me by email or Twitter to give you some more tips. Thank you again, Adele, and your team at eSynergy for hosting. It's been a really nice opportunity to talk to you guys.